Very good, and you?
Oh, a bit sleepy, but other than that.
You have a beautiful background. Very nice. A little bit of more blue sky and sun would be nice at the beach, maybe. But
it was a gray day. Yes, that's a beach near here. So.
All right, so let's wait a few more minutes until people join. So where are you located? Is this the beach nearby?
Yeah, I'm on Vancouver Island, a place called Victoria in Canada. So.
Oh, it's incredibly early in the morning. I'm sorry.
That's okay. Yeah, it's the west coast of North America is like that. So hey, that you knew where Vancouver Island is the best part there. So.
Yeah, no, I've never had the pleasure to be there, but we're about to change the schedule. So maybe if you're going to attend more often, then times are likely becoming more pleasant for you.
Oh, that's nice. And where are you located?
I'm in France.
Oh, nice. Where in France?
Southern France. It's somewhere. It's a technology park called Sophia Antipolis between Nice and Cannes.
Okay. No, I know where that is. When I was 14, I lived south of Paris and took troisième in the École de Pablo Picasso, and so my French isn't great anymore. But I used to have a near Parisian accent when I was younger, and but I have such fond memories of living in France, and I'm pretty sure I can still draw the country that's what we were taught in geography class. So yeah, I actually got to see Notre Dame one last time before it burnt recently, and that was so sad. I didn't make it up onto the roof this time because I don't know if you've been to. I imagine you've probably been there before, more recently than me, but the lines in Paris these days to see all the sites are just insane. It's don't get me wrong, there's lots to see, but holy smokes. Not like when I was a kid.
No. No, you should carefully choose when to go there.
It's true.
So the queuing times are insane. I completely agree.
They really are. However, it was wonderful to be in Paris that for a few days before I was actually taking the TGV down to Nice for a thing I was doing. So it was good. A lot of fun.
All right, so you know the area very well. Cool.
I don't know about very well, but sufficiently that I know roughly where you are. Also a very beautiful part of the world. So
definitely. All right. So hello everybody. I'm not sure a few more. Hi Victor. And Zaspas, never met you before. All right. So let me try to recap where we were last time and what we have discussed last week Tuesday and last week Thursday. So first thing, there is this doodle ongoing to change the time slot to make it more friendly for the US West Coast. But there are a few peoples only that participated so far. I'm going to share again the link in the chat. So please, if you haven't voted yet, vote on a time that is maybe more convenient for you. Let me search. Where's the chat here? All right, there's the chat. Second thing is, as I mentioned during last week's meeting on Thursday and Tuesday, we came up with this table to better structure the different threads, and I started basically putting all the existing content in these tables. And let me share the link to the document, because otherwise you don't have any clue what I'm talking about. So this is the document now that it has been moved to the OpenSSF Google Drive. And in this document, we try to document all the different threads. Quality is getting better slowly, but still it looks a little bit unstructured at times. But as I said, I started moving all those bullet items of the threads section into those simple table format in order to improve on how we document all this stuff. Right, I hope I didn't finish until today as I hoped, but yeah, there are a few bullet items missing. Right, and then I basically, other than that, while kind of consolidating and writing and this stuff, I came up with a couple of questions. But maybe and SAS, or all of you, in fact, you haven't participated in the past, if I'm not mistaken. So what we basically do is we try to go through the different systems of what we assume a typical development environment of a large-scale development organization, and then system by system we try to come up with a list of threats to the integrity and the confidentiality of the software that is developed by this development organization. And those threats can be exercised by, for example, malicious open source packages being downloaded to the different systems as part of the development lifecycle, or could also be due to malicious actors and malware otherwise entering the network and the premises of that development organization.
Yes,
so
yes. Actually, I glanced through this document. So one thing I think we can add is the scope of this document. That what is the depth and breadth we are trying to cover here. For example, IC, CI, and CD, and then we are publishing the package internal package repository. But we are, I mean, after these are all left to launch. So anything, I think, right to launch, that taking the package repository and deploying into the target repository, I mean, target deployment environment, maybe on-prem, off-prem, is that out of scope? That was my first question. I didn't see any threat or any best practices covered here. Maybe that is out of scope.
I have questions as well, but
I'm sure let's hope maybe I can answer a few, and if not, we discuss and anyhow we come to a common agreement. So the question is whether kind of off-prem and on-prem production systems are in scope, right? So so software that is running on premise at the customer is out of scope. So here we basically stop at the upload of any proprietary artifact on a distribution platform of the development organization in question. Could be one that they own themselves, maybe a download server operated by, by Acme Corp, or it could be, another marketplace operated by somebody onto which they upload their artifacts. So, and then this is where the customers get it and operate it on premise in their own environment, but that again is out of scope. What we thought would be in scope is, and this is at the bottom of this architecture diagram, is basically cloud services where the artifact is deployed in the cloud environment and operated by the same organization. Does this answer your question?
Yes. So in that case, the configuration code, the infrastructure as a code, security of that, how we can secure, those are also subjected to supply chain attack, right? So those will become in scope, right?
Exactly. Let me share the screen, and so I can point you to the respective sections. And of course, whenever you feel like there's something requires further clarification, feel free to go in suggestion mode and propose something to the text right away. I have always a hard time kind of running through the session and taking the notes and everything at the same
No,
time.
I
So
will.
please,
Yeah. No, I'm sorry. I will do that. But yeah, since I've just started joining, that's why I'll do that.
That's all right. Okay, so this is why, and we just did this last week or so. We included that assets being, let's say, requiring protection, if you will, is also system infrastructure configuration that is used by that organization for any internal system, including the customer-facing cloud services, if they have any. So this is this part here on the screen. Other than that, indeed, I can, and I just take this note here and I make it more explicit that kind of on-premise installations operated by customers are out of scope. To reflect what we were saying, I don't think so. Here, it's parts of the scope are also kind of implicitly provided by this architecture diagram we drew a couple of weeks ago, or months even already by now. Bian, you also had a couple of questions. Go ahead.
Yeah, so so I actually want to go back a couple of steps, if that's okay. Randall, you can blame Randall for this. He showed me, you can blame Randall for lots of things, but he showed me this, and just to give you an idea of my background, I've been in both proprietary and open source software for about 30 years. So I'm very familiar with both this and how, for instance, the kinds of things that you're bringing in from what you call third-party locations in this particular document. The first thing that came to mind when I looked at this is I was expecting this to be a threat model that had to do with open source, and as opposed to forgive me, but this seems to primarily talk about proprietary software as opposed to essentially how to mitigate open source as a threat is how I read this document. And so, and I don't mean that meanly at all. I'm just looking through this and I see open source in a red box to the right of the diagram that you've drawn. I see a whole bunch of inputs, and it talks about the proprietary side of things as essentially being effectively safe, and the open source inputs as being potential threats. And that has not been my experience. It's in fact been the proprietary sides of things where I've seen the most threats come into my build chain. That's the first piece, and I apologize that it seems to be undermining the entire point of this conversation. but I think a better title would be a great way to mitigate that lack of I was expecting one thing and found another. By the way, I'm not going to say that the drawing and the things you're talking about are invalid. They're not. This fundamentally follows how cloud services are developed and put together, certainly in my experience and so on. My background, the second piece is that I am also in the, most of my world has been in the embedded or appliance side of things. So starting prior to cloud even being a thing. And indeed, I was a part of a number of different groups that ultimately built a lot of the things upon which many of these things are now being used on a regular basis. There's a whole piece missing if you go beyond cloud here, okay? And that's on the side of when you're talking about physical things, there's whole parts where you have to get into like the production box that you have down at the bottom. When it's cloud, it goes into production, it goes onto your cloud service and you're done. In the embedded worlds, you have manufacturing, you have testing, you have a whole bunch of other things, and there's all the beta phases, the multiple different hardware versions that you go through, and other pieces like that. So I guess what I'm trying to say is that the two pieces are, I think this really has to be called essentially, you know, take this as a terrible start for a title, but basically this should be called not so much threat, the threat, what do you call it here? The threat, the open source software foundation threat models, but this is a proprietary development system that has inputs, some of which are open source. Again, terrible name, but I think that needs to be labeled better. And I don't mean this meanly. Like I said, I think if people are coming here to see how to secure their open source software, this is not it. But the second piece is that I'm not sure that the model that you've described here essentially is sufficient for all situations. It covers one, albeit a very big particular model. That the point is that there are, you know, if you're building cars or phones or televisions or you know, aircraft, it's way more than this.
Yeah. So yeah, thanks for all the feedback. That is so much appreciated.
I'm sorry.
I agree that no, don't be sorry at all. Really,
I'm Canadian. I have to apologize.
So in regards to the title, indeed, that is not very self-explanatory, right? So I agree. Maybe we should improve this and, you know, focus or explain that the focus is on these threat models for proprietary development infrastructures.
That's
so I agree. I agree to this.
It doesn't have to be changed right now, but
no, I just, but otherwise, if I don't take a comment, and we don't have a dedicated scribe, I will have problems later on.
I can do that though. You keep going. I'll make a comment.
All right. Okay, then I'll let you do this. Then, secondly, by no means I wanted to kind of suggest that open source is in any way more insecure or anything than proprietary software. Maybe this is in parts due to the unlucky color code that has been chosen at some point in time that is reinforcing this message. But,
it's a historical thing as well, unfortunately. A lot of people only see threats from the open source side. I see it all the time in defense companies and security companies and so on as well.
And so I completely agree with you that this is nonsense. So many times, just because of things being done in the open, people actually show more excellence and produce more secure software than people doing this, you know, behind the walls of some company that, you know. So I'm all with you here. It is true that especially in the first few kind of editions of this meeting, we were focusing a lot more on particularly these malicious open source components that were published so and so often in the recent 2, 3, 4 years. All right,
it's true.
And so this is one kind of attack vector in order to, you know, inject malicious stuff onto the different systems that you see on the diagram.
It's true.
And now this has been opened a little bit also to other, you know, channels through which malware or malicious actors can enter such a system, such as phishing emails or so. But it's true, it's really about then how to protect the confidentiality and integrity of the stuff that is developed. And maybe the last point, it's also true for embedded software. That is also due to my background. So I've been working for SAP for many years, and I've witnessed the shift from these enterprise monoliths running on premise to the cloud. And so this is kind of my background. So I'm lacking experience in this part. So
No, it's fine.
here, contributions are welcome to understand how this can be modeled. I think the challenge always is how to put it all into one diagram. And
it's true. It's so true, and that's why it's difficult to make that argument, because certainly most of what you've drawn here is the way every industry has if not moved to, have wanted to move to. So it's like cloud is a really good starting point. It's just that when you deploy to cloud, it's relatively straightforward, and the tooling is quite wonderful now. We don't have that same thing in other areas where you're manufacturing things. You start getting into rapid deployment is not something that's easily done, is the problem. So, but no, it's otherwise, like I said, what's drawn here and most of what's here otherwise framed in the appropriate way, I would agree with many of the things here.
All right, so maybe I can, in order to make this more explicit, come up with one additional note and highlight that the architecture diagram shown is not at all or insufficiently covering embedded software development.
Or all situations, that's right, fair enough, yeah.
So let me just, give me 2 seconds.
Exactly.
This does not describe. But mostly reflects about application software and services, I would say. Yeah, do you think it is possible to, you know, add a couple of building blocks to cover this better, or would you say that also the threats and the challenges are so different that it will just dilute and make it even more complex than it is already now, and so better not cover it?
So I would argue that the part that changes primarily is the blue box at the bottom. I'm further up the document. It's too small on my screen to read what yours says.
Yeah.
Let me give me a second here. I think you just call it deploy cloud app C, I think. So test. I'm sorry, at the bottom there. I think primarily that is the part that changes. So more than anything else, the kinds of threats that you have down there are several, and the biggest problem that we have when you're building things, actually, that you introduce new threats, because amongst other things you have things like contract manufacturers and others, where you're basically shipping things through VPNs, or in some cases physically, into factories that you don't necessarily control physical access to, or the networks and other things like that. And so if you're manufacturing in, and this is going to sound terrible, but if you're manufacturing in a Western country, maybe the US, Canada, France, there's one thing. If you then go to secondary manufacturing locations where you start manufacturing at scale, because quite frankly, it's too expensive to manufacture in our own countries. Mexico is a very common place, at least for North American companies, to go. There are problems there that you have to worry about surrounding people gaining access to things. The security surrounding contract manufacturing there seems insane, precisely because they're worried about these kinds of things. And then, of course, when you start getting to real scale, this is when you go to places like China or Taiwan or Vietnam, and things are very different again. And so the idea of people gaining access to modifying You know, there's all sorts of threats at that level. You're behind essentially firewalls that you really don't control, that are under state level you know, threats and that sort of thing. And so and then of course once products come off the line, of course they can be modified before they make it back to you, and so on and so forth. So there's all sorts of other threats that come up just through manufacturing alone, or upgrades that happen outside of your control as well. So I guess what I'm trying to say, and you know, lots of fun if you have to deal with that sort of thing, like I've seen and helped with in the past. So it's like I said, it's primarily that bottom box that changes more than anything else. Cloud, certainly the last 20 years, the tooling to the bottom box in your drawing for cloud has become quite wonderful and magical. For the rest of the manufacturing world, it's still difficult.
So what I take from what you say is that because of, you know, other organizations, other legal entities, and other legislations,
yes,
being involved, this whole thing becomes much more complex. Also due to the fact of, you know, producing physical items, that maybe we can keep this out and at least but have it properly documented here.
You can maybe just, if it's described, and again with the appropriate title and the appropriate framing, such that one talks about this as being a purely virtual dealing with a virtual end result or something. That doesn't sound quite right. A cloud back anyway, you know what I mean. The point is that mitigation in the words can certainly help. Again, framing it appropriately is what's important.
Completely agree here.
Yep.
Okay, let me.
Because what's being described here is valuable, and certainly, I would argue is as they say, you know, motherhood and apple pie stuff. None of this is rocket science if you've been doing this for a long time. The problem is that a lot of people don't do this.
Yeah, I guess I only covered half of the complexity you were describing, but
I can look at it and tweak it myself as well, so that's cool.
Right, good. And so for the title, all right, you already left a comment. Great, thank you so much. No, that's definitely helpful. To frame
just
this
very
better
heavy at this point, I know.
and manage the expectations better. No, that is fine.
That's it. Managing expectations.
Yeah. No, I'm thankful for all contributions and input. All right. So I'm not sure whether you have. I mean, you're attending for the first time. SAS is attending for the first time. I'm not sure how many other people are there. These are the ones that I see on the participant list right now.
Randall is the only other person.
Yeah, but he has been already a valuable discussion partner in the past, so I don't need to repeat so much for him here.
Sorry.
And so the idea, so we came up with this table, with these tables, and maybe we can discuss a few questions I came across. And during the process, you will learn, or at least I'm not sure, you will not learn much, I suppose, but at least you understand how we have been working on it. And again, any suggestions and improvements are highly welcome. So let us start for a change, maybe at the bottom here. So far, private repositories, right? So kind of company internal registries where artifacts are mirrored for the consumption by the internal build pipelines. We have touched upon them, not really, but in the process of the discussions, I noted down kind of two early, things that can go wrong, and in this context, I wanted to discuss a few things. So the first one we mentioned then is basically because vetting processes, if any, can be incomplete or insufficient. So maybe they don't look at the right things, or they don't look deep enough. You have you have malicious component being mirrored in your internal registry, and from there on, it becomes and is available to the internal build pipelines. I tried to move this into those boxes, and then when writing this a little bit down, I basically named it the mirror a malicious component. But then in the description, I already noticed that there can be many different ways or reasons for why you mirror a malicious component. And this is the original stuff that we kind of wrote down, or that I wrote down in one of our previous discussions. But on top of that, I basically found that there are probably plenty of ways to misconfigure these internal registries, right? So examples for these registries would be Sonatype or JFrog. These are the most prominent commercial ones. I'm not sure whether, do we have some open source alternatives here, by the way? That would be.
So I can speak to Yocto project and how Open Embedded does these things. So again, going back to the embedded side of things, Yocto project, Open Embedded use the same, one is built on the other. It has its own internal mirroring mechanism for keeping track of software. And one of the reasons why it's become the de facto build system, and in fact, it implements much of the drawing that you have at the top there. In fact, almost all of it is built as a part of the system. But it is used very heavily in all areas of building things that are used in infrastructure and things that we buy every day at the store and that sort of thing. But the way that works essentially is that when it comes to building things, especially using open source, the kinds of threats that it deals with are things like upstream servers being down, basically upstream developers misnaming things appropriately, changing things without changing the name, making sure that what you download is what you downloaded last time, or that the recipe author intended for you to use, so that you don't get weird changes, that things haven't changed on the way through, a threat actor doing a man-in-the-middle kind of attack. But so the mirroring initially was designed around solving those specific problems. However, we also have something called a pre-mirror, and what a pre-mirror allows you to do is to specify, instead of an upstream mirror, because the project actually mirrors software at a location that's actually run by the Linux Foundation. You can actually have your own mirror, and you'll find that let's say the companies that are more paranoid than others, and again, these are companies like security focused companies, like literally companies that sell security, and defense organizations and so on and so forth. They tend to only allow internal, they only allow software that comes from a pre-mirror to be used during the build. And so the way they work is they will, they actually have a team that will ingest software tarballs or Git repositories. It then goes through their process of basically making sure that it's vetted, and then it goes into the mirror, and that's the pre-mirror, and that's what it's built from. But external sources are not directly allowed in those situations.
Okay, so wait, so in your case, if I got it right, a pre-mirror is basically a clone of the source code repository from which the component is built that is added to the mirror?
So I perhaps didn't explain it appropriately. So in a lot of situations, we have these things called recipes, And for each component that we're building, and there could be hundreds to thousands of these, we download either a specific tarball, which usually has a version number in it if it's done properly, or it's pulling down an entire Git repository typically, which is then cached to make sure that the next time you go back to it, it's still there. Now this can be done globally, as we do in the project, to make sure that upstream sources, if they go away, we still have access to it. But like I said, you can actually have your own local mirror that we call a pre-mirror, in the sense that we check it before we check the public one. And what this ultimately means is that we have three sources that we can get something from. We can get source code from a pre-mirror, which basically circumvents the whole mechanism. We can get from upstream sources, or we can get it from effectively the backup mirror, which is the third location. So what state level, what governments and defense companies and security people do is they only take things from the pre-mirror. They do not allow the other two to work. You can turn those off. And so they basically have a security team that looks at the software, regardless of whether it's open source or proprietary, and vets it before putting it into a pre-mirror, such that you can only pull software from what you're building, source code, pardon me, from those locations, from those vetted locations. But I mean, for instance, just as an example, if you're building software for a missile, you don't exactly want, source code to come from, a Git repository on GitHub that's been updated yesterday that you haven't looked at, sort of deal. That's
Very
a real
obviously
thing, by the way. That's a real example.
And I don't want to know those really. And so this setup that you have just described, this is part of this Yacto project.
Yes.
And
it's part of it's part of, yeah. I'll say yes.
All right. And so, which I'm unfamiliar with. And so, sure. but I still imagine that there is we started from the idea that there could be misconfigurations in the way those mirrors are populated, consumed, maybe the order in which requests are happening. Maybe you pull first from the pre-mirror, and if you don't find anything, you go to the public upstream one, and so forth.
Not setting the pre-mirror, yeah.
Or not setting any at all.
It's still a misconfiguration, kind of yeah.
And so I wonder, do you think in terms of and we had this discussion also in the past, do you think it makes sense to, how granular do we want to keep this here? So I started coming up with this kind of one, let's say basically misconfiguration being one thread resulting in the consumption of malicious components. The examples I came up with basically, and so again, I come more from this application level world. So I speak more of Maven repositories, Maven agreed. Mirrors or so. Right. And so here, one possibility could be, you can set them up in such a way that you basically blindly mirror everything from the upstream from public repositories. You create a copy, and which is protecting you against the downtime of public repositories, but that is not doing anything on top. So you could just mirror happily the malicious component.
Exactly.
Another one is that basically, suppose you have a vetting process in an organization, you need to kind of enforce and properly configure the approved components. And of course, there can be plenty of hiccups and misconfigurations related to this. So I guess what I'm asking here is, how detailed do we want to keep those threads? Or do we just say, when it comes to running an internal registry, there are plenty of possible configuration problems, and then we come up with a non-exhaustive list of such problems? Or do you think it is worthwhile? I guess this would be, I think this is my preferred approach, because otherwise we probably end up very quickly in technology specific things.
Yeah, it's true.
So maybe can we add a few examples? So if you agree to this, maybe it makes sense to add a few examples here in terms of what could be misconfigurations. What do you think? Or do you, yeah, or maybe you have another idea altogether?
I'm just thinking about the ways it could be messed up in my specific context, because you've thought about your own like Maven basically, and a lot of the other mechanisms replicate what we do essentially internally with Yocto project. Instantly, I put a link to Yocto project in the list there. Sorry,
Yeah,
in the chat.
great.
Rather. Yeah.
Okay.
I see what you're saying. Yeah. Let me think about that some more.
You know what? I think go away, chat. I think I do this here and maybe try to see whether I can, because for this one here, for the private repository, we just have these commercial examples, and I think it would be nice to have, in fact, open source examples for all those systems and features, and maybe even only open source alternatives rather than commercial providers.
The problem is artifact repositories are having recently tried to do some research on artifact repositories. There's a couple, although I can't, off the top of my head, I can't think of them. But one of the reasons the proprietary alternatives exist is because there aren't that many available that aren't just essentially web servers with directories that people are synced to, more or less. So like if you look at a Yum repository, or like a Debian package repository, for instance, or a number of other things like that that are used as a part of some of the systems I'm talking about, they're essentially just directories on a web server. So,
yeah, for me, one of the strong points of those commercial vendors is that they support so many different ecosystems and programming languages, right? And that's why they are there.
Absolutely.
And so
I'm just saying, it's hard to list open source alternatives to those, because of course the scope of those that what you've listed are very large. And I'm not, again, not criticizing. What I'm saying is I'm not sure we have an equivalent open source artifact repository, is what I'm saying.
All right. So since we started discussing this, so I basically tried to remove this bullet item I highlighted here on the top. I wonder about the likelihood of misconfigured internal package repositories or package registries. And again, it's very difficult to come up with something covering such a wide spectrum of.
I would say initially it's fairly likely, but I would say over time it's less and less likely. Would be my take, but I'm sure other people have a better idea. That's my initial thought. I think
what we were talking about in this one was, for example, in Homebrew, it's happened before where, because Homebrew uses a DSL, someone will put a malicious link so that Homebrew itself will pull from a malicious link. And because people don't actually check what they're downloading and whatnot, it has happened where we like accidentally merge that, and then we end up on Reddit.
Is just a quick question? Is this something that is happening on the client of those guys? So this is not something that is misconfiguration of the internal package registry, but more a misconfiguration of the local package manager, which we have discussed as a threat to the developer machine, where we already have misconfigured Maven, and we can maybe take up here.
With Yocto project, it's on the developer machine, not on the end user's machine. Yeah.
Because what we were trying to say is that if this were to happen, Homebrew would take its stance that basically Homebrew is not at fault because we are not a software security or a like gatekeeper of what gets in a Homebrew and what doesn't. So if we merged it, it's because it looks good and it basically acts like a duck, so it's a duck, at least from our purview. And if you're using Homebrew, it would be of the opinion that maybe you should check the formula before you install it.
That's too late.
I totally agree, but you and I both know that there is this sentiment does exist amongst packaging community.
Oh, of course it does. Of course it does.
All right,
I don't agree with it.
Yeah. All right, but then one quick question. This sounds more like this is either a vulnerable or a malicious package that has a recipe configured that results in pulling yet other components from an attacker-controlled repository, right? So this is more the attack vector here is a malicious package on Homebrew, not a misconfigured thing.
I think you can step back a bit further because that's certainly the result. I think that the threat, not the threat, the development threat here is that Homebrew was the Homebrew developers were tricked into accepting essentially a formula that was malicious. This is like the whole kernel community accepting patches that were that introduced security problems in the kernel from the University of Wisconsin. Anyway, same kind of thing, right? So the end result, of course, is the end result. But the point is that, as Randall said, looked good to me, so they merged it, and so it's more a matter of the process by which external code was merged was attacked. There.
Okay, but the end result is malicious stuff ending up on the end user and or developer machine when the developer being the end user at some point.
Do you remember when Audacity got sold to that Chinese company and they basically started packaging spyware? That was one of the days that basically Homebrew ended up on Reddit because they were like, how do you distribute this stuff? And their response was like, because our job is not to like tell people like this is what you need to do with your software. You can do whatever you want with your software and it's a valid update. So
it's done by a Russian company now.
Yeah, I think it was a Russian company. It was a Russian company. But yeah, basically the point there is that like, and Henrik and I have talked about this. What do you do when like a developer decides to go like political?
One thing that I find, so I understand the problem, but that from the perspective of what we are modeling here, this is something that went wrong outside of the scope of this development organization, right? Something got wrong. Maybe it's the open source Homebrew guys, or maybe, I don't know, the developers of some open source project start pulling and declaring a malicious dependency. But the end result from the perspective of this development organization is the same, that it consumes a malicious piece of software on, in different systems, right? So I wonder whether we can describe this, whether it makes so much sense to distinguish this here as a different threat, or whether the threat is not simply you can consume malicious
it's a separate
pieces
threat.
of software.
No, I think you're saying here mirror malicious component. You're basically saying copy and then continue to reuse software from an external input. I think what's being discussed here is more merging a patch that is malicious is the threat here. It's a separate threat.
Okay, but this we have. So we have malicious commits, but this would be commits that happen in the source code repository of that organization. We have a couple of, right. And we have, I think, of course, this consumption of malicious packages, and this whole private registry is kind of a variation of consuming malicious components through that channel. In my mind.
If I know I think Randall mentioned before, for everybody to adopt SBOM is pretty hard. But if everybody adopt SBOM, then is it possible to catch those like those just vendor purchased by another nation state or whatever, and then put in malicious code?
No, because it was a perfectly valid update.
Yeah,
SBOM, it will not catch that.
No.
I don't believe it does. No. I'm not sure what we're discussing is a malicious commit, because it's accepting a patch from a third party. A malicious commit, it talks about, and I don't want, at the risk of derailing things here, the malicious commit talks about a malicious actor, like a developer going rogue or malware making a change. We're talking about a third party patch coming in and not it being insufficiently vetted before being so it's either an expansion of the malicious commit threat or it's a new threat.
Okay, so it's basically go ahead, Victor.
Will that patch come with any information such as SBOM?
No, sometimes.
So SBOMs are for the, well, this is my understanding. SBOMs are for the software as a whole, not for individual patches. What we have for in open source, at least, is something called DCO and the developer certificate of origin. And so we know essentially who it comes from, and it should match the person that's sending the patch to you, typically. And so in theory, we have a place where we know who wrote the patch or who is claiming the patch, so that we know where each commit basically came from in, say, the Linux kernel or other projects that have adopted the DCO mechanism. So in theory, we know where they've come from, or at least who claims to have produced the patch. The point, however, though, is that a lot of these things come in through email, and of course, email can be subverted. And so if something comes in, let's say from Linus Torvalds, weirdly, he's sending a patch to the Linux kernel mailing list, and so on and so forth. The fact that it's signed off by him and so on and so forth, somebody maybe just merges it.
Of course.
Right. And that's the issue is that, you still have to look at the software and go, okay, well, this is causing a buffer overflow. Maybe this is a bad idea.
So I still wonder, do we need to update and reflect this anywhere? I mean, it's difficult for you to answer because you didn't read through the whole document, and
I just read back through it really fast.
But for me, kind of malicious commits. So first of all, I mean, the way that patches are submitted via email for the Linux kernel, for example, that is something that typically would not happen within such an organization, right?
Actually, it does. And the reason why is because the kernel that people use in embedded, quite often, it's not a mainline kernel. So it usually starts as so we call them vendor kernels. And so they're typically forked kernels, and then you typically add patches from other locations that solve specific problems that haven't made it upstream. Now, in ideal situations, that doesn't happen. But you'd be shocked how different kernels are on the average things that you probably even have on your desk right now, different from an upstream kernel. It's shocking. But
I don't have any device under my desk.
Okay, but, your desk is far cleaner than mine. Fair enough. Just reading through your document, though, you do have malicious approval. And so I think you actually do have a threat here that describes what I'm talking about. So perhaps I'll look at that later and see whether it needs a little extra bits. I think you do have it.
The idea here of the malicious commit and the malicious approval would be that basically they go hand in hand in case there are kind of review processes in place. Maybe sometimes they're not, but maybe you have one developer machine infected, it's doing a commit, it requires approval, and that can be done by, I don't know, by another infected developer machine after having understood, what are the typical roles of the people in this particular development organization, right?
Infected developer, I see. Okay, it's not quite the same then. I got it. I see. I see.
Um,
Okay, fair enough.
I
perhaps
mean,
it's
here
not.
we speak of malicious actors, right? And this could
Agreed.
be either somebody going rogue, could be malware running on that system, doing it on behalf of the guy sitting in
Right.
front of the desk.
What I'm describing is somebody says this doesn't work. Oh, look, I found a patch on the internet that solves this problem. I'm going to merge it into my kernel or whatever kind of thing. That happens a lot.
Yes,
And again,
I wonder whether So I wonder whether this is a technique that can be used, because what you're describing, this is more the somebody who is maybe not security aware enough, and
which is most developers.
who doesn't he doesn't realize that he should not copy paste stuff and integrate it without deeper checks. And so I wonder whether this can be misused by an attacker, basically to place content such that the likelihood is higher that it will be picked up by somebody.
That's exactly what I'm saying.
Okay,
that's precisely what I'm saying.
So here, one threat would be maybe some attackers creating a question and upvoting answers on Stack Overflow,
for instance,
to make sure. All right.
That's absolutely bang on. That's exactly the problem right there. Yeah.
Okay, so then I don't think we have this yet. This is somehow
I don't see it. Yeah.
So that is something for the. I put it here to the developer machine, because it will eventually be done from by the developer sitting on his machine. All right. So
agreed.
Then, how can we name this thread here then?
I think a to-do is probably a good idea, because we're running out of time.
Yeah, we're on the top of the time of the hour already. Okay, so I note this down. How can I remember this? Attackers upvote Stack Overflow.
That's a
to have it integrated by developers, or copy paste it without any further review.
It's kind of like an SEO attack, isn't it? You put the appropriate keywords in, and as you say, upvote it on Stack Overflow, and look, there's the patch I need. It's true.
All right, no, that's a nice one. Thank you so much. We didn't really get any further here, though. Maybe a quick question to resolve this for me. So my take would be, for this private repository, that we have two threads. One is for the time being, and it can be detailed and split up later on. One is all about misconfiguring such private repositories, and the second is basically about wrong, insufficient, incomplete approval processes or vetting processes that they only look at major releases but not at minor releases. And so if there is a malicious software in the minor release, they wouldn't get it. Or maybe they look at when vetting, they look at the source code repository on GitHub and don't realize that this does not correspond to what they download from a binary repository. It's kind of flawed vetting processes.
How about, is there any way of indicating that a vetting process has occurred? Are there any mechanisms that I'm not aware of, any mechanisms that certify that something has been vetted?
No, not that I know. I mean, it's
yeah, I wonder if something like that is a good idea.
Yeah.
Because if you're getting something from a known good mirror, I mean, how do you know that it hasn't been attacked?
Yeah. No, but the idea, I like the idea of kind of certifying, if you want, certifying a vetted component. So to have kind of a label attached to it that it went to. It reminds me a little bit of some of the what's the name again?
So I'm thinking like an SBOM, but for security sort of deal. So like basically a file that lists a commit or a SHA 256 that's then signed by the person who did the vetting, so that you can then say, okay, this person said that this commit is, it's a mitigation to this problem as opposed to an actual problem. But I'm wondering whether something like that exists, because then the issue would be, you know, not having a certificate of being vetted for security.
So I put it here as a, I don't know, vetting for a lack of a better name, but vetting certificate. But I think there is, I need to look this up. This would be a control, right?
It would.
To make sure that component consumed has been vetted.
Well, then under mirror malicious component, then it'd be insufficient insufficient documentation of being vetted.
I'm not sure where are you.
So under mirror malicious components,
right.
you said a component allow list resulting from a vetting process is not properly configured. I'm suggesting mirrored software not being sufficiently documented as being vetted. So yes, it's in the mirror, in the known good mirror, but in fact it's not good.
Mirrored, or part of the mirror contained, or part of the mirror.
In other words, isn't certified as being vetted,
even though it has not been certified as being, yes.
Turns out all this stuff is very complicated.
And so, but all right, I wonder, this is kind of more this is basically the impact, right? So this is not a description. So the description is due to some misconfiguration happening, stuff ends up where it has not been vetted. And so that is, and that is more the, I'm sorry, I put it here at the first bullet item. So this is more the impact, right? No. No.
Oh, I was just thinking, if there is a certification mechanism, if there is a certification mechanism saying that it has been vetted, that it's not being that certification is not being validated, is the misconfiguration that I was describing. However, I think at the moment, I think we've at least initially ascertained that it doesn't sound like there's a mechanism for doing that yet, or we're not aware of a mechanism that guarantees it's been vetted, other than it's in the known good mirror.
Yeah, I think I'm lacking the name here, but I think there is something. I will look this up for the next session, I hope. All right, but other than that, you agree on these being at least two different threats. The one is this whole misconfiguration thing, and then
yes,
other is related to the vetting processes being having hiccups, let's say.
Yes.
And so I will actually move this down here, which is the incomplete, insufficient vetting process, which is kind of actually a broader description of, or more general description of one of the problems that is in here, which is they just look at the different artifact. Okay. All right, so you see how this is how quickly the time passes, right? So it's I don't know, it's always gives me the feeling that there's just so much more to do and to discuss. Feels a little bit like a Sisyphus. But yeah, again, I'm quite happy. Please.
I have a question. The doodle that you sent is talking about next week. I'm at a conference, an embedded conference next week. Is it an ongoing thing, or is it just...
Yeah, exactly. It's written in the description. So the idea is it's a recurring meeting, and so this is just to find the day of the week and the time.
Got it. I will. I've enjoyed myself today, and would love to come to future ones. So I will.
Henrik, if you don't mind, would you mind adding me to that doodle so that I can get it in my email and fill it out, because I had misplaced the link.
It's in the. Oh, no, you joined after the chat, didn't you?
Yeah, I did.
I think are you on the Slack, OpenSSF Slack?
Yeah, I am.
Okay, then I will send it to you on Slack.
Awesome. Yeah, sorry
Right.
for joining late. I have a bit of a
And
cold.
no worries at all. All right. Is there anything else that I need to write down before it is forgotten, or that you want me to write down?
I think we're good.
All right. Well then, thank you so much. And hope to see you. So as of the next week, maybe last word here. So since we have until end of this week in order to vote on this new time slot, I would say that I think we should have next week again have it on the 3 o'clock, and then we, as of the week after, we start on the new schedule. Would be my proposal. All right, guys. Thank you so much. Thanks for attending. I wish you a nice day. Bye-bye, everybody.
Thank you.
Thanks,
Nice meeting
bye.
everybody. Bye. Have a great day.